Hello, everyone. Thank you for joining today's webinar. Today's webinar topic is why upgrade to Ekahau Sidekick. As you know, in September, we released the first ever purpose-built Wi-Fi site survey device. And actually want to take some time today to walk you through what it is, what it's used for, and how it actually helps you save time troubleshooting, among a ton of other great things and great features about this product. So today our webinar will be managed by Yusi Kiviniemi. He's our SVP of Solution Strategy and Customer Experience here at Ekahau. Jerry Ola, who's also a technical engineer. And Brian Harkins will join as our moderator. He's our Training and Enablement Manager here at Ekahau. Before we get started, a couple of housekeeping items. You're in listen-only mode, so your lines are muted. In order to submit a question, please type your inquiry into the questions pane of the control panel. And you may send those questions in at any time during the presentation, and one of our subject matter experts will address them during our Q&A session at the end. So again, thank you everybody for joining, and I am going to turn it over to the team.
All right, thank you so much, Latisa. Jerry, Brian, are you there, guys?
Hello, sir. Hey, you see, this is Jerry.
Good morning, Jerry, and good late evening, Brian. Brian, I understand you are in Singapore, is that right?
That is correct, sir. And you are in Finland today?
Correct, and Jerry is all the way in Wisconsin. So we have a very multinational, multi-geographical webinar going on today. My name is Jussi. I run the janitorial duty, so I make Jerry and Brian coffee when we're at the same office. Jerry, who are you?
Who am I? Good question. I am a technical solutions architect, CWNE number 238. Yeah, happy to be on here talking about something near and dear to my heart, you know, Wi-Fi and spectrum analysis and all that good stuff.
And Brian, how are you, man? You still awake? It's like midnight there, right?
It's midnight, so I'm still going. Old men can stay up late if we want to.
Right.
I'm the training and enablement manager at Ekahau, and so far everyone I've had an opportunity to share Sidekick with has been almost as excited about it as I've been.
Which is fairly exciting, right?
It's tremendously exciting.
That's good to hear. So yeah, today we're gonna talk about like what are the differences between other solutions versus Sidekick in terms of Wi-Fi engineering, Wi-Fi design, troubleshooting, and we're going to run through a few slides first and then jump right into live demonstrations, if that's okay. I hope everybody can hear us okay. If you can't, let us know on the QA board, on the questions board. Okay, let's get the ball rolling. Jerry, you wanna? What is this about? It's the road versus your Wi-Fi network analogy again, right?
Yeah, I mean the challenge with Wi-Fi, you know, first and foremost is we can't see it, right? So analogies come in pretty handy with trying to explain Wi-Fi and explain especially the challenges that we deal with when it comes to Wi-Fi. So I think the road is a good analogy to kind of represent what our Wi-Fi network, you know, is, or you know, at least you know, visually be able to connect that. So kind of think of the road as our spectrum, and you know, then we've got lanes, and we've got you know, kind of rules and regulations and things like that to be able to use the road. So I think it you know, it ties in pretty nicely.
It really does. And anything can happen on the road, right? And that's why we need some kind of headlights to really see the road, because yeah, Wi-Fi is like a dark road, right?
Yep. Yeah, that's a good point. I mean, not just a road, but yeah, like you know, you've got your road, but if you don't have any lights and you know, there's no street lights, there's no headlights in your vehicle, you know, we're still driving on that road blindly, you know, similarly to navigating our Wi-Fi network. So I thought it made sense to kind of connect that, you know, with headlights on a vehicle is similar to the insights that we can get by having appropriate tools to be able to visualize, you know, what's happening in that RF environment. And without those headlights, you know, if we're trying to, you know, drive our vehicle or engineering vehicle, if you will, to troubleshoot a problem, you know, it's going to be pretty difficult to spot an issue and be able to identify an issue on the on the road, on the spectrum, without the right tools to provide that kind of visibility into our network.
Right, and there's just like there's LED headlights and the traditional kind and anything in between. I guess with Wi-Fi tools, there's also differences, right?
Yeah, headlights can burn out, right? Gotta upgrade our headlights. Maybe add some fog lamps on there. You get the picture.
Precisely, and some provide more visibility, some less, and the reaction we got from our customers in the last years is no matter how much visibility we gave them, they just seem to be craving for more visibility. They wanted to kind of see the picture more quickly, kind of be able to focus on the big picture of Wi-Fi more quickly and get their stuff done out on the field more quickly. Apparently, exactly, pretty much when Netflix and HBO announced, the Wi-Fi engineers seemed more and more willing to get to their hotel rooms more quickly. That's the kind of correlation we saw. I don't know if there's something there maybe. They just wanted to go. New season of Narcos. They wanted to get back to the hotel more quickly. Anyways. What about this one? So yeah, they just needed the extra visibility, not just to see farther, but more like see more focused, right?
Yeah, not just clear picture, but being able to identify these issues quickly. I think is what kind of the focus is here on this representation of stuff can pop out, right? As far as interfering devices, they can come and go and things like that. So if we don't have something that can quickly identify these issues, the issues can be very difficult to troubleshoot, and we could be having could be wreaking all sorts of havoc on our network without us being able to catch those interferers and things like that as they're kind of popping in and out of the RF environment.
Exactly. So all kinds of things can bump into your way. Jerry, what is this about then?
I don't know. Sometimes we get some interesting things showing up on our networks. Some unexpected, either interferes or maybe this is your legacy client really bogging down the spectrum, right? Really taking up a lot of your bandwidth there, a lot of your airtime. Can definitely cause some congestion in your traffic.
Is that a genuine picture from your home street in Wisconsin, by any chance?
I was thinking that was in Finland, but you tell me. I'm not sure where this picture was taken.
It would be Finland, but the picture lacks the polar bears and igloos and vampires.
I did see a headline recently in Wisconsin about a kangaroo that was crossing the interstate or something, which, that's not something we see in Wisconsin here. Maybe in other parts of the world they run into that problem. But, yeah, that was a big headline around here. Apparently escaped from a local zoo. But, yeah, you can definitely see how this would have a pretty devastating effect on your Wi-Fi network if this is the impact that's a device is having on your spectrum.
Yeah, I would say too, it's not just this is Brian. It's not just the legacy client itself. It could be that the access points are under deployed, and it's a current client at a greater distance using legacy modulation techniques, and that's harder to find without the right equipment.
Precisely, and with all the low data rates enabled, you might have a client like very, very far, operating very, very slowly, despite the modern technologies that it supports when it gets closer to the AP. So, typical Wi-Fi engineer's toolkit these days. What do you guys think? Lot of components, a lot of moving parts there, right? So this is a fairly high-end Wi-Fi toolkit today, and it does a good job, right?
That's a fantastic job. From that setup, it looks like you're able to scan both bands at the same time, do throughput testing at the same time, and scan layer 1 with the spectrum analyzer, which is all something that you need to do.
Exactly. And with this setup, though, you would only be able to scan one of the spectrums, or either spectrum analyze 2.4 or 5 gigahertz, because you only have one spectrum analyzer, right? the good thing about that is most of the noise today still is on 2.4, and most of the interference is still on 2.4. But since 5 gigahertz is the kind of the primary frequency these days, it's like, which one do you want to spectrum analyze if you only have one spectrum analyzer? Do you want 5, which is more important, or do you want 2.4, where you will more likely kind of encounter the issue? Which one would you guys choose if you only had one?
As far as which band to analyze, if you only had one option?
Yeah, if you only had one spectrum analyzer, like in here, would you scan 2.4, which is more frequently interfering, or 5, which is more critical to your network performance these days?
Yeah, I mean, it's going to depend on the clients and the environment, right? So if you really care about 2.4 and that's an important band, then, that would be, your limiting factor there. And, honestly, what you may need to do is actually make 2 passes, right? So take twice as much time if you're only using a single spectrum analyzer that can analyze one band at a time. The other side of it is if it's a high density deployment and you're looking at the health of the 5 gigahertz side, having the 5 gigahertz data is going to be really important from just the health of the RF environment, the health of the spectrum.
Yeah, that's a perfect answer. I think you need to scan both, but it's hard to pick which one to choose if you don't know what the clients are you're supporting. It's a given there's noise in 2.4, but the more critical devices are now in 5 gigahertz. So if I had to pick one to scan, I would just assume there's noise in 2.4, and I would track it down if it caused problems and do a clean sweep in 5 for my plan. But I'd rather be able to do both.
Absolutely, absolutely. So yeah, just like discussed, different moving parts here, and I'm an aesthetics kind of a guy, so even though the cabling here is really, really nice and the setup is professional, still a bit too much cabling to my taste. But then I'm a Scandinavian, and we are all about simplistic design. I mean, we sit on a rock if given the possibility. And we eat rocks as well, but that's because we're poor. Anyway, Jerry, any thoughts on this picture? I think it's one of your designs.
Yeah, so this is just to highlight, as we go into the Wi-Fi toolkit progression here of how we've transformed the toolkit from, just needing to analyze a small amount of spectrum to now being able to, needing to analyze a lot of spectrum, right, is kind of the emphasis here. So we started with just a single, passive survey adapter, and that was good enough to just give us some visibility, some insight into the RF environment. And then we moved on to, all right, we need not only that passive information, but also spectrum analysis information. And then as the computer technologies advanced, USB, things like that, we have multiple USB adapters. We can link multiples together to analyze that additional frequency that's been given to us of 2.4 and 5 gigahertz, and then even adding multiple spectrum analyzers so that we can do what we were talking about there of being able to analyze both bands of the spectrum at the same time.
Exactly. And what about this? This starts taking us to the future already, doesn't it?
Yeah, things kind of progressed quickly, in recent years, right? So as we can see with Fernay here, he started, moving a lot faster, right? Is kind of the emphasis here. We need to cover more ground more quickly. And with having multiple adapters, that kind of enables us to do that, right? So by having multiple adapters, we can move faster and still collect all that valuable information that we need. But yeah, where do we go from here, right? So, we can't just keep moving faster and adding more and more adapters, right? So we need tools that are purpose-built, that are lightweight, that are, not sucking all the battery out of our devices, because all these things, more adapters we plug in, the more power that it drains from our internal batteries. So we needed to build a purpose-built solution for this.
Precisely. So some of the challenges here, like using multiple adapters, USB hubs. So here we have a total of 3 Wi-Fi NICs plus a couple of spectrum analyzers plus one extra there hanging on the side. There is those challenges of not just aesthetics but attaching them. And to me, it's always been the USB power has been the big issue. So limited number of USB ports, providing perhaps limited amount of power. So you kind of struggle to get all of this working on a single laptop. Some people have external battery packs that they carry with them. Some people have like powered USB hubs. We see all kinds of creative solutions. I'm sure you and Brian, Jerry, you've seen all kinds of creative solutions out in the field.
Absolutely, yeah. That's definitely it's definitely been interesting to see some of the hodgepodge kind of setups of making all this work. And there's been some really creative solutions with the hub holster of just figuring out ways to attach all this kind of stuff. But yeah, you're right. At the end of the day, we still run into that power constraint of limited number of USB ports, and we're not seeing any additional USB ports being added to new computers. Right, we're seeing fewer and fewer ports to connect this stuff to. So we need a solution that can handle that.
And then there's the whole not just getting enough battery power or not getting enough power out of the USB port, but there's the laptop battery life issue. And this is what I run into all the time in the field is, well, best practice is you need to have your laptop charged when you go out to the field, but still, when you have all those dongles in the laptop, it does drain quite quickly. And Jerry, you ran some tests as well on this.
Yeah. When we were initially, kind of exploring this whole thing of, the battery drain that we were seeing from these devices, we were seeing the battery life of these laptops being cut by about 40%, just to power, 2 passive survey adapters and 2 spectrum analyzers, which is kind of the ideal setup, I think, for anybody analyzing both bands simultaneously.
Exactly. And then there's the noise from the USB hubs. For example, USB 3.0 hubs, they just create a lot of interference. And of course, so do internal Bluetooth and Wi-Fi radios. And I myself, I like to turn off Bluetooth while I site survey, not just from my laptop, but also from my phone to kind of get a better understanding of the 2.4 spectrum without carrying those interfering devices that might affect.
Yeah, and USB 2.0 hubs, especially good quality ones, if you need to buy a replacement or anything like that, they're becoming harder and harder to find. Most of these are becoming discontinued and end of life, so you're kind of forced to go with USB 3 if we continue down this path, which has all these additional challenges that we have to deal with and face and be aware of.
Just a side note, we have our first ever troll in our webinar, trolling us with questions that are irrelevant to the content of the webinar. But there's a milestone right there. Anyways, moving on with the show. Wi-Fi drivers and driver installation, of course, with external adapters, you need customized drivers to really get maximal performance and kind of maximal features set out of them. And that's a good thing because we can control them, but at times, Windows may have a life of its own. It usually, everything goes like in the movies, La La Land, but not always. And don't we hear quite a bit about the Mac support, or what do you guys think? What do you see out in the field? At least to my experience, Mac is more and more commonly used among the engineers.
Yeah, it definitely seems to be a trend, right? The Mac side of things, Mac platform. I would say there's also been an increase in the tablet side as well. So we're kind of seeing both sides gaining in popularity with like the Surface Pros, and then also the MacBooks. Given their lightweight and they're also just additional capabilities with packet analysis being built in, makes it an ideal solution for a wireless engineer.
Sure. So Jerry, you want to drive this?
Yeah. So let's talk about kind of what's next here. So are we going to an AR type setup, right? We've been hearing a lot of talk of augmented reality, virtual reality, that kind of thing. Would that be the next step of our toolkit? Well, based on the issues that we identified there in the previous slides, I would say probably not, right? So that's not going to be where we're going today. Maybe somewhere down the road. What else? Where else might we take this? So we could look at bringing back the express card support and adding a new express card adapter, but that doesn't make a whole lot of sense, right? That's not the direction we're heading. What else? What other direction might we want to go with this? That looks a little more of addressing some of the issues and challenges that we were talking about. So what's this here? This is looks like some kind of wearable device that has a single cable that would connect to a laptop or a tablet, right? So yeah, that's I think the direction we want to take this. What do you think, UC?
Yeah, absolutely. I mean, we need professional measurement equipment, and we also want state-of-the-art user interfaces today and tomorrow. So maybe it makes sense to kind of separate the measurement equipment, make it as easy to carry as possible, as easy to attach as possible, and keep the user interface then separate from that measurement unit. And that was kind of the thinking there. And also, why didn't we just make another USB dongle? It's because if first of all we would need 4 or 5, and we didn't want to run into those USB power issues or drain the tablet or laptop from its power. It's kind of the thinking here. So that's a check mark, I guess. So enter Ekahau Sidekick, and we're going to go through this quite quickly, because all of this you can find on our website ekahau.com or sidekick.ekahau.com. So a Sidekick is that all-in-one device that's kind of meant to be an alternative to 4 or 5 different dongles, hubs, things like that. Connects to the laptop or tablet, and just makes all those measurements, spectrum analysis, as well as Wi-Fi. And that's an actual real-world person, one of the few who already have their hands on the Sidekick, carrying it, right? And the good thing about Sidekick is it has some pretty beefy internals in it. So the spectrum analyzer is dual band simultaneously, 2, 4, and 5 gigahertz all the time at maximum resolution, and it's ultra fast and it's ultra accurate. So compared to traditional today's tools, it's like 10 times faster, 10 times more accurate. And we can get a glimpse of the speed and accuracy, what it really means, quite quickly. But the most common thing with spectrum analysis is you have to let the spectrum analyzer sit in one location for a while before you can actually start building a picture of what's going on in the spectrum. But with Sidekick, the second you turn it on, in 1 second it's already made 20 sweeps of the spectrum. So in 1 second it builds you a very crisp picture, and it just goes from there, as opposed to having to wait for 60 seconds if you have a less granular and less speedy analyzer. And then we have the dual NICs. So to allow quick scanning as you walk around the site, we wanted to put in 2 802.11ac Wi-Fi adapters in there for Wi-Fi signal and noise measurement and getting the information out of the Wi-Fi APs that we so desperately need. Plus, these are the we tested several different Wi-Fi radios for this purpose, and these were the most accurate, linear, consistent units we could find. So also, it's the device is battery powered. So, and this was the Jerry's testing. So you can increase your battery life in your laptop by 40%. And it's pretty simple to use. I mean, you just wear the Sidekick, connect it to your USB, and start Ekahau's software, and there you go. Very straightforward and kind of error prone. So it's either plugged in or it's not. It's either turned on or it's not. And if it's both plugged in and turned on, you're good. So there's no like am I getting enough power to power all of those dongles? And you can more and more kind of offload some of the basic survey responsibilities to the slightly less trained Wi-Fi technicians, and maybe take more a role of a Wi-Fi designer, architect, optimizer yourself. Oh, and it brings Mac version out of beta as well. Since Sidekick is 100% platform neutral, there's no reason why we wouldn't have full versions for Mac as well as Windows. So last question. By the way, Jerry, Brian, are you guys still there? I feel like I went into...
I hope that's not the last question.
I dozed off a little bit there at the end, but I'm still here.
Yeah, I can't blame you. I doze off when I listen to myself, so... That's why I do coffee all the time, man. Anyways, so Sidekick is shipping now. There is a bit of a backlog still, so if you haven't received your unit, it's not like we don't like you. It's just that the demand is very, very high, and we're shipping, you know, first in, first out type of a scenario here. And you can buy through our partners or directly from us, whatever is your preferred method of purchase. And Ekahau, you need Ekahau Site Survey 9.1 for Sidekick, and if you order Sidekick, you will also receive a beta version of ESS 9.1 today, and in December the final 9.1 will be out for both Mac as well as Windows. Just to get an understanding on how Sidekick actually works, and this is especially fruitful if you already have ESS and a spectrum analyzer, and even if you don't, go check out this video for a couple of minutes. We'll wait for a couple of minutes. Please go to this URL. I know you have to. Can we actually, Jerry, since you're not sharing full screen, could you one more time send this link to all the participants over the chat board?
All right, will do.
Thank you. So go check out this video. It's like 4 minutes long. We won't wait that long, but you kind of get the idea of the speed of the spectrum analyzer and also of the new real-time frequency monitor, or RTFM 2.0, that ships with ESS 9.1 that has a few new features with it as well. So go check this out. You can see on the chat board, Jerry has posted the direct link, so you don't need to manually type it in there. Go see the video, and we'll be back in 2 or 3 minutes. During that time, Jerry Ola has promised to sing us "God Save the Queen."
That would be not nice to these lovely attenders' ears.
Dude, that's not what you said like 30 minutes ago. While they watch the video, we have questions here. One from Anders Nielsen. Will Blake Roney be added as an accessory in the future? Because that was a picture of Blake with his Google Glass, right?
That was.
We just have to miniaturize him so he's easier to carry.
Yeah, make like a
shrink ray.
Blake-shaped Roomba that would do the surveys for us, right? There's a question from Daniel. Can the Sidekick do GPS surveys too? Yes, if you have a GPS unit. Sidekick itself does not have GPS, but the GPS functionality is something we will also be improving in the coming years. There's a question about, will a smartwatch interfere with the survey being so close to the arm and body? The answer is yes, to some extent. I think it will. Or what do you guys think?
Yeah, I mean, that question has come up a few times, and the thought that I have behind it is, you know, yeah, it will have some impact, but compared to our traditional adapter-based setup, you know, there's going to be impact one way or another. What is the more realistic in the real world, I think, is the way the Sidekick is kind of designed and engineered to be used and worn, of, you know, potentially on your side like that would be similar to where a lot of our users are, keeping their devices, right? So if you think of it from a portable device standpoint, a phone or a tablet, keeping in your pocket, that would be a similar location to what that would be. So it would be more realistic to the perspective of those clients.
Yes, sir. There's a lot of questions on the price of Sidekick, and the list price in dollars is $2,995, and in euros it's something like $2,795 or something like that, but less than $3,000. And if you compare it to some of the competing single band spectrum analysis only devices, which are a lot slower, which can cost $4,000, here you get dual band spectrum analysis at multiple times the speed, multiple times the granularity, plus a couple of state-of-the-art Wi-Fi radios, plus a battery. So in that sense, it's not very, very, very expensive. And then there's a question, I see only 802.11ac, what about 802.11g or n? Well, 802.11ac, yes, absolutely. Also 802.11n and g and b and a, so everything, yeah. Sorry about that. We actually should be more consistent, because AC indeed is only on 5 gigahertz, but definitely this is 2, 4, and 5.
Yeah, and both radios are dual band. They're both 802.11ac radios, but they're dual band where they can analyze both 2.4 and 5, not simultaneously, but with having 2 radios, obviously you can do that simultaneously by having one sweeping 2.4 while the other sweeping 5, or at least break up the channels appropriately, and the Sidekick will do that automatically for you by default.
Precisely. And there's a question of battery life of Sidekick. We didn't really touch that too much, but it's 8 hours. 8+ hours is the battery life. So it will last you all day. And it's of course rechargeable. So at this point, before we take more questions, maybe jump back into the presentation. And Jerry, I see you have taken over, which is the only sensible thing to do. I was already ruining the webinar.
I'm taking over this webinar.
Resistance.
All right.
And you also
All right.
forced me.
How does this look on your guys' end? Does it come through okay?
Looks like a beautiful piece of software engineering.
Excellent. All right, so this is a demo here. I want to go through a couple of things live. So, always fun doing live demos here and see if we can, break something in the process. So let's see how things go. But I did a survey recently and identified some interfering sources in the environment. But first, what I want to look at is the live data from the Sidekick and show the value that adds from a, like what we were talking about in the beginning, of just the visibility that it provides me to the Wi-Fi network around me here. So if I pull up the real-time frequency monitor, similarly as we have in the past, I get a lot of the same information here with the passive survey information of measuring those signals, as well as the spectrum analyzer built into the Sidekick, as well as I can do an active survey at the same time. So if I go to the connected devices here, you can see I'm seeing the 2 radios that we talked about in the Sidekick, as well as the spectrum analyzer. And then I have my internal adapter here that I could choose to put into either like a ping test mode or a throughput test mode. And I could set this to talk to the endpoint on my network here. And we can see up on my live display here, I'm getting about 100 megabit per second on my network. I need to upgrade my access point. Apparently in my lab here, it's a older 802.11n, but still able to get over 100 megabits per second on this AP. So this will work good for testing this out. And we can see now that energy increased quite a bit on the radio that I'm connected to, which is highlighted here. So this is telling me my survey device is, my active adapter here is connected on channel 44, and that's a 40 megahertz wide bonded channel. So let's look at this data a little closer here. So I'm going to put this in the pop-out view mode on the real-time frequency monitor, and we can even blow this up into full screen if we want. And now we can start to dive into these, channel 44, 48 that I'm generating all this energy on while I'm doing the spectrum analysis, and we can see how efficiently it's kind of making use of these channels here. So if I zoom in, nice and close on there, We can see right now we're kind of analyzing this subset. Let's zoom in all the way onto those 40 megahertz just for really to show off more than anything. But now we're getting into like subcarrier level visibility of the actual RF energy here. So just to show the level of detail that we can get to troubleshoot and analyze this data. What's some of the other things that we can extrapolate out of here? So we can look at, obviously these pretty colors and visuals here, but let's look at some statistics. So if I go to the channels view here, I can actually see the spectrum utilization, and you can see while I'm doing this throughput test, I'm actually hitting, all the way up to, we saw about 90% utilization at one point, and now it's dropped down to around 80% utilization on both of those channels. So you can see it's pretty evenly doing that. Curious, actually, now that I think of it, I'm over the Wi-Fi on the webinar here, so hopefully my audio isn't getting affected too much. So I'm going to stop that throughput test there.
You're good.
And we can, I'm good? All right. See, I got nice resilient Wi-Fi over here, even doing a throughput test and sharing my screen and everything at the same time. So yeah, here we can see now I stopped the throughput test. We can see pretty quickly that spectrum data change. If I go to the waterfall view, we can see how that changed. So notice when I was doing the throughput test, how constant the medium was busy, those channel 44 and 48, and now we're seeing some pretty good breaks in that energy. So it's much lower utilization here is what this is representing. If we go back to that channels view, you can see now that I'm just streaming my screen share and the audio as I'm talking here over the Wi-Fi. We're really only using about 10% of the airtime between both of those channels. So plenty of airtime available there. What happens when we, back to our slides in the beginning there, some of those dinosaurs pop up on the network, right? Some of those interfering sources. So I've got a couple of we'll call them signal generating devices here, and we'll see what happens when we bring these up and what this happens. So I'm going to put these on more the Uni 3 end of the spectrum here so I don't affect my signal I'm connected to. But notice how quickly that popped up as soon as I plugged in. This is actually a video transmitter, and happens to be a 5 gigahertz video transmitter. So some people say, hey, we don't need to worry about doing surveys on 5 or spectrum analysis on 5 gigahertz because all the interferers on 2.4. Well, I hate to say it, we're seeing more and more devices, non-Wi-Fi devices, popping up in that 5 gigahertz spectrum. So this just emphasizes the need to be able to analyze both of those. And I can zoom in nice and tight on there. You can see this is not a Wi-Fi device, right? This is a 5 gigahertz video transmitter, and definitely going to have some pretty devastating effects on the Wi-Fi environment. Actually, we can see that pretty quickly here. If we actually move this a little closer to my main channel, which is operating on channel 149, and we'll see if we can actually kind of block this AP that's in my environment here. So let's actually move this over a little bit and see if we can get that to align with channel 149. You can see as I'm kind of moving, it's dialing in those frequencies, and as we get that closer, once we get that close enough to that kind of main channel, that channel 149, notice what happened to my access point. Actually disappeared altogether. So essentially we're jamming that channel. This is where that access point used to be, and notice now I'm not getting any readings of signal from that access point anymore. So this is essentially acting as a jammer and is preventing me from being able to hear that access point altogether. And yeah, even from a spectrum analysis standpoint, we've stopped hearing that access point altogether, so we're not picking that up at all. So that's that, going back to the beginning of our presentation here, talking about that visibility that the Sidekick is able to provide you while you're performing these surveys, being able to see that, what does that do from a survey standpoint? So obviously we're looking at this live troubleshooting, this has a lot of value in itself, but what does that give you from a survey standpoint and a post-survey analysis? So let's close out of the frequency monitor here, and I'll flip back over to this survey that I had pulled up. And this is a survey of an actual environment here, and I located a couple of those video transmitters in this environment as well. So let's see what we can do with this. So we're looking at the normal view here, showing signal strength for my access points. Everything looks normal right now, but what happens if we dive into some of this data here? So some of the new views that were added is with the spectrum analysis integration is things like spectrum channel power and also spectrum utilization. That's going to look at just the raw RF energy. So if we look at just the Wi-Fi data, everything looks good, everything's green, but what happens when we look at things like spectrum utilization? Well, now all of a sudden something's kind of sticking out to me here. I'm seeing really high utilization in this section of the map, which normally wouldn't be a big deal if I had an access point in that area, because that would make sense. I've got an AP nearby. It's causing a lot of utilization. But notice where the APs were picked up during the survey is on actually kind of in between those areas. So we can see that high utilization. If I hover my mouse over there, we can actually see that pretty clearly, right? So 70 to 80% utilization affecting channel 149. There's another red flag. Why am I seeing so much utilization on channel 149 when my access points are operating on channel 36 and on channel 52? And it's just a single channel, so it's not a 40 megahertz wide channel or anything like that. So we could drill down into that. So if I go to my survey tab, survey inspector, let's kind of peel through the layers a little bit here and dissect this a little bit more. So we know that's on channel 149, so I'm going to flip over. I'm on my survey mode. I'm going to flip over to 5 gigahertz. And there we can automatically or already see, there's definitely some high utilization on channel 149 there. There's also a few other things being picked up. But let's jump to that spot on the survey where we saw the highest utilization. And I've already marked it on the map here with the little star indicating that, yeah, there was some type of interferer that was detected. And notice how much stronger that signal is now when I was in this area inside this room here. This is actually a laundry room. But yeah, very high utilization. So this is actually an OFDM signature, but it's not Wi-Fi. This is raw RF energy that happens to be kind of mimicking what an access point would look like. So pretty hard to tell. Into some tools, this might just detect this as another access point, or from an interference detection might think this is another access point. This is actually raw RF energy from a signal generator that's generating it at 20 megahertz wide, and it's chewing up utilization wise. We go to our utilization view here, 80%, 85% over a 5-second period of time. We can even lower that down further to like either 1 second and see if it changes. That's still about 85% there. And we could go up to like 30 seconds here, and we can see over a 30-second period of time, we were still seeing 63% utilization on that channel. Let's look at one other interfere on here, and we've got those same video transmitters that I was demoing live. So what does that look like from a survey standpoint? Well, these interferers, these video transmitters are really, they're fairly narrow, but they're really high power. So what we want to use to locate those would be spectrum channel power. So if I flip over to spectrum channel power, I've already adjusted my legend here to filter out anything that is higher than negative 23 dB in this case. So just kind of setting this to cut out the lower power signals that we are seeing, and I'm just looking at now any high power signals that were being detected during the survey. Well, I can pretty clearly see these big red flags here. We've got two things that were picked up at over negative 20 or about negative 20 or higher dB during the survey, and I can easily identify which rooms these signals were picked up in. I measured on this side of it; it wasn't very strong. When I went in this room, we saw a very strong spike in that signal. So let's pop up our radio frequency view here again, and let's look at that signal that we picked up there. So I'm going to zoom out so we can see the full spectrum again, and you can probably already kind of identify where that signal is coming from. If I hover my mouse over this area, we can get some more details about that signal and figure out what channel that might be operating on. So let's look at hovering over here. You can see the channels and which ones are greatly impacted. Obviously, channel 132 is definitely sticking out as the highest kind of power that was being measured there. So there's our channel 132. Flip back over to our recorded mode here. And let's go right in here. So actually, yeah, it's actually this channel 132 here is that measurement. So notice that same signature that we were looking at live before got captured very nicely in our spectrum analysis. And I can easily identify, the interferer is right in this room, right in this area here where I picked that up. Same over here. Looks like we've got another one. If I go to this spot, you can click along the survey path here, select these data capture points, and we can see again we've got another interferer. This one happens to be on channel 153, and we can see what that looks like. We can also look at the channel utilization and see what kind of impact it's having from a channel utilization standpoint as well. So yeah, that's I think a good kind of crash course of the capabilities, the value that the Sidekick is going to provide in comparison to the previously kind of USB-based setup. You can see how quickly I surveyed this environment and how much I was able to determine and pick up during this assessment. And if we look at the even the survey standpoint, like if we look at the survey statistics, I spent a total of 4 minutes and 35 seconds performing that survey. So under 5 minutes, I was able to identify 3 different interferers in this network and where they were located in the building.
Wow, you should deserve a medal, man. That's well done. That's very, very efficient, isn't it?
Exactly, and barely used any of my laptop battery either, because I was relying on the battery in the Sidekick, which you can see right now is at 70%.
Sweet. So yeah, there's been a lot of questions coming in. Thank you so much for those. Mainly it was about again, the battery life, 8 hours. The price of Sidekick is $2,995, so under $3,000. And if you get both Ekahau Site Survey Pro and the Sidekick, that's called the Sidekick Pro Pack. That's less than $6,000, and it includes everything: surveying, Sidekick, site survey features in ESS, planning, reporting, everything. So that's that. And what other main questions were there? Also, like, what about tablet support? So Windows tablets work today already, and all we can say as before is Sidekick is completely operating system independent. Okay, any other frequent questions? Should we take just a couple of questions here and answer them, unless there's still more demoing to do?
I'm happy to demo any other capabilities anybody wants to take a look at, but yeah, we can fire up some other transmitters and look at what those look like on the spectrum.
Sounds great. And while you do that, I'm going to take some questions. So can Sidekick gather both 2.4 and 5G data? Yes, from the spectrum analyzer and the NICs, both simultaneously, both bands. What Ekahau version do you use in this demonstration? You're using 9.1 beta, right, Jerry?
Right. Yep.
Will there be further touch optimizations in ESS? Says Tom Spinoza. Hey Tom, how's it going? Good to see you. Yes, there will be a world of touch optimizations for sure, to say the least. What is the upgradability of Sidekick units? So, and there's been a few questions on, like, are the radios interchangeable, stuff like that. They are not interchangeable, but then our previous NIC 300 was in the market for like 7 or 8 years, so it's probably not going to be required anytime very soon. Kevin Dawson says, how does sensitivity compare to USB NIC 300? It's comparable to the NIC 300, actually very comparable. What is the best tablet to use for ESS and Sidekick? What do you guys think? Best tablet to use for ESS and Sidekick?
I'm using a Surface.
Small and light with a large enough screen to display what you need to see, and possibly with a built-in camera so you can take pictures of mounting locations and obstructions as you go through. I don't know if there's a particular brand or model number that's better than another, It's about the feature set and what's comfortable and light for you to carry.
Yeah, personally, I'm using the Surface Pro to do this demo, and you can see, it's handling the Sidekick data and everything really well from a survey standpoint. Very lightweight, thin, good battery life. But yeah, to Brian's point, really from a form factor, I think that's the biggest piece that you should consider is the form factor and what makes sense for you as far as for carrying and for is this going to be a dedicated survey device, which I think the Surface Pro works very well at, but is it going to be your daily driver for using for all computing needs? There should obviously be some other consideration there than maybe just a tablet or Surface.
Fair enough. There's a question of what is the battery life in years, but there's no really number of years limit. Of course, like any lithium-ion battery, the battery will, if after 6 years of usage, it will not have 8 hours of battery life anymore, so it will slowly start to degrade.
Oh, and I saw there was also a question on, what happens if the Sidekick gets unplugged or something during the survey? Will it crash the application? So, that's always a fun test to do live. So let's go ahead and test that out. I'll go ahead and unplug the Sidekick here live, and you can see what'll end up happening in the software. Again, this is a beta, so we'll see if we can break it, like I said. But you'll notice I get a notification here saying the Sidekick was disconnected, and the beauty is plug that back in, and should see pretty quickly after the computer recognizes it being reconnected, start to show up again. And there you go. You can see here, Sidekick added, so it took just a few seconds between unplugging it, replugging it back in for it to pick that back up. We get a nice clean notification there saying that it was disconnected and reconnected. And that's really, it's hard to wrap your head around it, but the Sidekick is one of the biggest factors of the Sidekick that's a game changer is that we're offloading all that heavy lifting that your computer is normally doing with all the drivers and interacting with the hardware and the operating system to now being done on this purpose-built device that's doing all of the driver complexity and everything on the Sidekick. So that's where we can really improve the reliability and the performance on that kind of stuff.
Yes, sir. Then there's been several questions about the kind of, since Sidekick has good quality radios, how does that compare against phones and not so great radios? And I'm happy to say that the Ekahau Site Survey 9.1 final version will have a offset functionality where you can offset things for phones and laptops and things like that. So although Sidekick does report reading stronger, like any high quality adapter will report reading stronger than a phone or whatever, we have an improved all new functionality to kind of compensate for the offsets. And last time was today when we spent 2 hours just sweating over the fact that how do we make this like super precise and easy to use for the end user and overall reliable. But we're getting there, so ESS 9.1 will bring that functionality of compensating the differences between different adapters, different devices, and it will hopefully make a good job at it, or you can kick me out.
I saw a question on the resolution and high resolution displays. The Sidekick or the Surface Pro has a pretty high resolution display, and one of the things that I do like is that it does handle, and I don't know how this comes across on the GoToWebinar, but I'll try it out anyways, is the rotation. So the Surface Pro will automatically rotate the screen, and the Ekahau Site Survey application will snap to that as well. So now I've rotated it vertically, and it shows up on my screen at least, nice vertical, and you can switch on the fly between kind of that portrait and landscape mode while you're surveying.
Oh, and it didn't blue screen your computer either.
Exactly. Bonus.
So then there's been questions about warranty. As in Sidekick warranty, and is there a yearly fee? Jerry, Brian?
So 1-year warranty on the Ekahau Sidekick, and then as far as support and maintenance goes for things like firmware updates and those kind of things that go with a device like this, that is all part of your Ekahau Site Survey support and maintenance contract. So as long as you have an active support and maintenance contract, you'll continue to get those firmware updates for the Sidekick included.
Yes, sir. Yeah, 1-year warranty, no Sidekick-specific maintenance fees. Any issues with connection breaking between, I guess, between the tablet or laptop and the Sidekick?
Can't say. I mean, just like I showed in the demo, if you do, physically have some type of a disconnection for some reason, your cable gets pulled out. It's a pretty seamless, handoff of telling you the Sidekick got disconnected. You plug it back in, and you just pick up where you left off. You don't have to, close the project and reopen it or any of that kind of stuff. It's very seamless.
Very cool. A couple of more questions, then we're on full time, and I do apologize, I can't go over, but Brian and Jerry, if you guys can, maybe, because there's so many questions, is it okay if I just pass you the ball, and if you can go a bit over and keep hammering on the questions, because there's so much good stuff here that we really should be answering, but I do have a hard stop at 7 p.m.
I've been trying to keep up with the questions in the chat as we've been moving along. So I can stay on myself and answer questions if you need me to, no problem.
Yeah,
Jerry, is it okay if you guys carry on from here?
Yes, yeah. I will be able to stick on. Gustavo, I see you were referring to the connector, it looks like, on the Sidekick. Yeah, I can say, we've obviously just started shipping these products. Seems to be pretty reliable as far as the connector goes so far. So we'll kind of, I guess, time will tell, but this is obviously purposely built for, being in these kind of ruggedized environments and these industrial environments. So the Sidekick is very, industrial in that sense as far as the connector and the jack. The nice thing is the cable that it uses is a micro USB cable, so it's a pretty standard cable that you could pick up at your local electronics store or department store. If for some reason you break a cable or lose a cable or something like that, it's not some kind of proprietary cable. Looks like we've got a question here about GPS for outdoor surveys. The Sidekick will work with a GPS receiver. It does not have a built-in GPS receiver, but the Ekahau Site Survey software supports really any NEMA-compatible GPS receiver, USB, Bluetooth, whatever you want to use. I would recommend USB just to avoid the interference that you're going to pick up from like a Bluetooth. Yeah, you could connect a GPS receiver, or if your survey device has a built-in GPS receiver that's NEMA compatible, you could utilize that for the GPS piece. Obviously, I would have to be outdoors since GPS is not going to provide you any accurate location indoors. So yeah, I see some questions about how rugged is the Sidekick. So yeah, I mean, it's definitely purpose-built, for being, indoor, outdoor. It's, weatherized in the sense that it's, very, rubberized exterior, no open ports. There's no active cooling for, fans or, airflow or anything like that. It has a heat sink that's, visible on the outside of the unit. That's kind of that grill that you'll see on there. So it's built to be pretty sealed and pretty enclosed. Obviously, you still have some connectors on the bottom for charging and for the USB connection. But yeah, it's definitely meant to withstand the daily use that would be expected of any type of surveying device.
I've got a question here. Is the Sidekick the best option to get started as a new user? That's what I would choose. If you're looking at buying Ekahau Site Survey, you would want to pair the Sidekick with that if you're a new user. If you're an existing user, you maybe want to look at upgrading to the Sidekick. So if you're brand new, you'd be better off starting with the Sidekick than buying the USB dongles and then upgrading later.
Yeah, it's going to depend on, I would say, the environment that you're looking to survey and what you're looking to get out of that. Again, kind of going back to the beginning of our presentation here today, of the visibility. What is the visibility that you need to your RF environment and your network? Do you care about detecting these interfering sources and being able to see the health of the spectrum from a spectrum utilization standpoint, if that's valuable to you? I'd say hands down the Sidekick is going to be your best device to be able to provide that kind of level of insight to your network. You can absolutely utilize, if you already have the hardware, like the supported Metageek spectrum analyzers, as well as the passive survey adapters like the NIC 300s or the SA1 adapters. You can use those obviously all in combination to get similar results, but this level of detail, this level of resolution at this speed is really the where the value of the Sidekick comes in. And as we demonstrated with the survey that I completed here, being able to identify these interfering devices in under 5 minutes of a survey of this environment, you're not going to be able to get that level of detail and that much information in that amount of time. You're going to spend a significant amount more time, and you may have to make multiple passes in a given area or spend a significant amount of time kind of parked in a certain area before you're going to really detect these kind of interferers. I mean, these interferers in this map were picked up literally just walking in and out of a room, and I was able to get that level of detail as I walked around this environment. And we can see that too if I go to the survey mode here and we play this back, and we can see, like, as you walk away from an interferer, if I'm over on this side of it, you can see how these get much quieter now, these interfering sources. And then as I moved closer to them, over here, for example, we can see how they get louder as you move closer to them. And we can see, yeah, right here when I was just outside of this office, we can see how much louder that was. Now that there wasn't the obstruction of the wall since the door was open, there's no obstruction. We can see the signal is actually going off the charts here, essentially. Oh, and I did see a comment about, you can see this multi-purpose room 111 here. Somebody was asking, so if I go back to signal strength, and you can see how the middle of the room is filled in with signal. However, I didn't walk down the middle of the room. So I saw somebody asking about how do we measure, the middle of that. Well, if I really cared about signal specifically in the middle of this room, it would be potentially a good idea to measure that. However, this is a big open room with no walls down the middle of it, so really taking a measurement on one side of the room and on the other side of the room is sufficient enough. Because of the accuracy here, it's going to extrapolate that signal set to vary here. If I adjust this to super, we'll notice now it's tightened up there, kind of the fill-in work here that it was doing, where now I could see, okay, yeah, I do actually have to take a measurement down the middle of this room to fill that in. So we can use this to kind of fill in some of those gaps. Now notice I'm reducing my accuracy to being, instead of super accurate, being very accurate. So obviously it's telling me there, even though it's filling in that information, it's kind of doing some guesswork. It says, okay, I know the signal was this much on this side of the room. I know the access point, is coming from over here, and I know the signal is this much, where you measured it here. So I'm going to blend the two together and know in the middle it's going to be, X dB. Because let's say over here it was -50 and over here was -60. Well, it knows in the middle then it's probably going to be about -55. So it's going to give me a pretty accurate assessment without me having to physically walk through all those areas. Now also notice I have signal prediction turned off. That's another kind of just personal recommendation that I have when I'm surveying, is I always like to have signal prediction turned off. If you turn signal prediction on, you'll notice it's going to use some guesswork of, okay, it knows the APs are here, and it's going to extrapolate that signal, doing some combination of measured and predicted signal based on the measurements, the location of the AP, and do some additional guesswork there. So, I always like to keep signal prediction turned off while I'm surveying, just so that I'm only looking at measured data and I'm not looking at any of that kind of blended predicted data at the same time. When it comes to reporting, that's where I might want to turn signal prediction back on to kind of smooth some of that out and make the picture look visually nicer for reporting purposes. But from an engineering standpoint, troubleshooting, I like to turn signal prediction off and have actually accuracy set to super to only be looking at those kind of raw measurements that were taken. Any other questions, Brian?
Here's one. How much RAM do you need to run ESS with Sidekick? It's not really a question of Sidekick impacting the amount of RAM. You need the RAM for ESS. So just whatever your laptop is using currently with USB adapters would work fine with Sidekick as well. It's not going to increase or decrease the amount of RAM needed because it is really 3 external adapters and a battery in a box. It's not additional software or forcing any new processing inside ESS.
And yeah, like I mentioned before, the Sidekick is actually doing more of the heavy lifting now with decoding the frames and things like that that were previously being done by your operating system, your host operating system. Now the Sidekick is doing all those processing on the Sidekick itself, and then passing the measurements and the visualization data to ESS, or passing the data to ESS to visualize it. But yeah, all that heavy lifting that was being done previously by your laptop and the adapters being plugged in is now offloaded. Any other questions? I see we're a few minutes over here. Let's flip over to the 2.4 band here. I'll generate a signal on one of the, using a kind of a frequency hopping signal generator here, and you can see even on like the 2.4 band how clearly it is to pick this up even though it's rapidly sweeping through at 10 kilohertz a second through these frequencies. Actually, it's 50 millisecond hop, sorry, 50 millisecond. Every 50 milliseconds it's hopping through here with the 10 kilohertz speed. All right. Well, thanks everybody for joining the webinar. Letisa, are you still on the call?
I am still here. So really great session. Thank you guys so much. Thanks for everybody for sticking around. And if there are any other questions that you have, any additional follow-up, please feel free to reach out to Brian, Jerry, or UC. They've all shared their information. And thank you again for joining, and we look forward to seeing you on future webinar sessions.